So for Lab 6, we're going to be continuing to work with fMRI data, this time with a similar but slightly different task. So this is again an associative memory task, but it's looking at face occupation pairs. So let's start by taking a look at the task. This is a similar design to last time, where first we have the reaction task, where you'll see the letters Y or N. Y stands for yes, N stands for no. If you see Y, press the right button. If you see N, press the left button. Then we have our memory task. You will then see photos of people and text stating their occupation. Memorize what the particular person is doing. Does the occupation seem like a good fit for the person? If yes, press the right button. If no, press the left button. And finally, the recognition task. You will then see photos of persons and their occupation again. Does the person match the occupation as you memorized before? If yes, press the right button. If no, press the left button. So let's see what this looks like. So starting with the yes-no task, where they're just responding to the letters they see on the screen, followed by the study block, the encoding task. So now they're responding yes if they feel like this is a good match, and no if not, and just trying to encode the occupation with the face. And finally, does the person and occupation match based on what they'd seen previously? And so now, when they have these with the question mark, they're trying to remember if these are face occupation pairs that they saw before. So for the paper that you'll be writing later in this class, you will be comparing the data from the word pair associative memory task and the face occupation task. So you should think about what might be different in terms of encoding pairs of words versus encoding face occupation pairs. So the last thing I want to show you is a website called Neurosynth. So this is a pretty cool website. If you're not familiar, you can do a couple different things with it. So one of the things that Neurosynth does is it automatically creates meta-analyses by searching terms in the abstract of different papers. So if you go here to meta-analyses and you click on terms, you can search for all kinds of things. Let's say I want to know what kind of brain regions are associated with the term reward. So here I can see that the term reward is in the database. I can click on it and it's going to show me brain regions that are found across a lot of different studies that basically just have the term reward in their abstract. Another thing that is cool with Neurosynth is you can also do the reverse. So instead of starting with a term and then finding brain regions that are associated with that, you can also click on different locations in the brain and find out what kind of studies tend to find activation in those areas. I can click on a random part of the brain. Let's say I want to know what's happening right over here. I'll click on what's here, and it's going to do a couple different things. One is it's going to show me what's called a functional connectivity map. So that means what other brain regions tend to have correlated activity with this brain region. So for example, when signal in this brain region goes up, it looks like signal in this part of the brain also goes up. And this happens to be a network that is known as the default mode network. We can also click on these different tabs, and here we can find studies that find activation in that area that we clicked on. And if we click on associations, we can see different terms that tend to be associated with that region. And so, for example, here you can see default network is coming up because basically what we're seeing is the default mode network. And the default mode network often is active during resting state tasks. So that's another term that comes up. So I think this could be a fun way, if you want, to just explore the brain and the kinds of studies that are associated with different regions.